Sci-fi spends billions inventing monsters, but the universe doesn't need imagination to terrify you. Somewhere out there are worlds where it rains glass sideways, where the ground is a lava ocean, and where a planet is being pulled apart by its own star. These places aren't rumors, they're documented by NASA. So tonight we travel to the planets that feel like horror. Our first stop is a planet that looks beautiful from a distance but is a nightmare up close. It's HD 189733b, a world NASA says possibly has sideways glass rain and howling winds. This hot Jupiter orbits dangerously close to its star, with clouds laced with silicate particles, the stuff of glass. NASA reports winds ripping around the planet at 400 miles per hour. That's planet-wide violence. The rain is a continuous shotgun blast of tiny glass fragments. The weather itself is a weapon. And if you think that's the worst place we'll visit, our next planet has no safe ground at all. Because the surface is molten, there are deaths that are fast. Explosions, collisions, and then there are deaths that are slow and humiliating, a long unraveling. WASP 12b is a hot Jupiter so close to its star that tidal forces distort it into a football shape. That alone is unsettling. A planet physically stretched by gravity. But it gets worse. NASA's Hubble team describes something that sounds like a myth until you realize it's a press release backed by observations. The planet's atmosphere has expanded to nearly 3 times Jupiter's radius and is spilling material onto the star. Let that sentence sink in. A planet bleeding into its sun. In the language of gravity, WASP 12b has wandered too close to the boundary where a star's pull can strip a planet. It's not a clean event. It's messy, gas streams away. The planet loses itself bit by bit. If HD 189733b is a world where weather kills you, WASP 12b is a world where gravity kills the planet, and it forces a terrifying thought. If our own solar system were arranged differently, if Jupiter had migrated inward, if Earth had formed closer, we might not have been here to have this conversation. This is one of the reasons hot Jupiters fascinate astronomers. They hint at violent histories. How do you even end up that close? Did the planet migrate inward? Did it scatter through gravitational interactions? The details are complex and research continues. But the observable horror is simple. The star is eating the planet. Now if you're thinking, okay, that's extreme, but at least you can see it, our next planet is terrifying for the opposite reason. Because you can barely see it at all. Not because it's far. Not because it's hidden behind dust. But because it's dark. There's a fear older than monsters. The fear of darkness. TRES 2b is famous for being one of the darkest exoplanets ever measured. NASA's exoplanet catalog calls it the planet of eternal night, noting it's less reflective than coal and may have an eerie deep red glow from its hot atmosphere. Why is that scary? Because reflectivity, what scientists call albedo, is how we understand atmospheres, clouds, energy balance. A bright planet usually has reflective clouds. A dark planet absorbs energy. TRES 2b reflects less than 1% of the light that hits it, according to NASA-affiliated summaries like the Smithsonian's write-up, which notes it's blacker than coal. And Princeton University's news release on related analyses described the planet as absorbing an astonishing amount of light, helping scientists understand how atmospheres can gobble starlight. So imagine orbiting this planet. The star is bright, but below you is a void, not a peaceful night sky void. A material darkness like the atmosphere itself is engineered to swallow light. Now the honest scientific answer is, we don't fully know why it's that dark, and that's what makes it mysterious in the best way. Scientists suspect missing reflective clouds and chemical absorption, complex atmospheric chemistry that turns incoming light into heat rather than reflection. In a horror film, darkness hides the monster. In astrophysics, darkness is the phenomenon. This planet is a reminder. The universe isn't just violent. It's also strange, but we still have one planet left. And this last one is not just hot. It's so hot that it breaks molecules apart. It's so hot it starts behaving like something that shouldn't even be called a planet. Kelt 9b is the kind of discovery that forces you to recalibrate your imagination. NASA describes it simply. It's so hot that the heat tears molecules apart on the dayside. NASA has also explained that Kelt 9b has a dayside temperature around 7,800 degree, about 4,300 degree, hotter than some stars. Let's translate that into human language. On Earth, a blast furnace melts steel at around 1,200, 1,300 degree. Kelt 9b is operating at temperatures several times that. It is a planet trying to exist in conditions that feel illegal. And when you heat an atmosphere that much, you don't just get wind, you get chemistry unraveling. Molecules that would normally stay intact, like water vapor, methane, even basic compounds, can break apart. In extreme cases, atmospheres can stream away into space. So what connects these 5 terrifying planets? They're not cursed, they're not evil. They are the predictable outcomes of physics. Put a gas giant too close to its star. You get violent winds, boiling atmospheres, strange chemistry. Put a rocky planet too close. You can melt the surface into a lava ocean. Put any planet too close for too long. Tidal forces stretch it, and a star can strip its atmosphere. Change the chemistry and cloud physics. You can create a world that reflects almost nothing and becomes a dark planet. Go even closer to an even hotter star. You get Kelt 9b, molecules torn apart by heat. Meaning, these planets are not cosmic exceptions, they're cosmic possibilities. And once you accept that, you start seeing Earth differently. Not as the default, but as a narrow, safe corridor through chaos. There's one more concept that deserves a quick, honorable mention, because it's the kind of thing sci-fi uses a lot. And reality can be even stranger: tidally locked planets. NASA explains it like this. For a tidally locked planet, there is no normal day and night, only freezing darkness on one side and burning sunlight on the other, with a twilight terminator zone between. This matters because many potentially habitable planets around red dwarf stars may end up tidally locked. So even the worlds that look promising can have nightmare climate setups: a permanent furnace side, a permanent ice side, violent winds trying to equalize heat, and a narrow strip where conditions might be stable. Not all tidally locked planets are doomed. Climate models show a range of outcomes, but it's a reminder that habitable zone doesn't automatically mean comfortable. So what's the real message? It's not space is scary, that's obvious. The real message is this: science fiction trains us to fear aliens, but the universe has something more frightening: indifference. It doesn't hate you, it doesn't chase you. It simply creates worlds according to physics, and most of those worlds are hostile to the kind of life we know. Earth is not protected by destiny. Earth is protected by balance, distance, atmosphere, magnetic field, water cycle, plate tectonics. A stable star, change a few variables, and Earth could stop being a home. It could become a different entry on a list like this. If a sci-fi writer pitched these worlds in a script, someone would say, too unrealistic, but they're real. They exist right now, quietly orbiting their stars, obeying physics, doing what the universe does. And if we ever become an interstellar species, our first enemies won't be aliens. They'll be the planets themselves. If you want more science-based storytelling that you can actually verify, hit like. If you want the next episode, subscribe, because we're building a series of the most extreme worlds ever found. And comment below. Which planet terrified you the most? Glass rain, lava ocean, star eater, eternal night, or hotter than stars? I'll pin the most interesting theories.